Hi, I wanted to talk about model traffic lights. Probably seen those little models, lights for railroad layouts and towns and things. There's about 10,000 circuits on the net. Problem is they're all the same circuit. They use a counter, 10 consecutive outputs. What they do is they send these four for green, that one for yellow, those four for green and yellow. Combine that for the red on the other side. And it sort of works. You get green, yellow, red. Problem is, if that's a 2-minute green, you're going to have like a 24-second yellow. You want to wait through a 30-second almost yellow signal? Kind of unrealistic. So let's look at something better. Okay, the first thing we need to do is define what we want exactly. That would be timing chart, where we would have green, yellow, red, and red, green, yellow. This just keeps recycling around. So we can create a couple of waveforms. For example, this waveform, so we can get with these are equal. I can't draw worth shit, so you can get that with a 555 timer. That would give us our green, yellow. And by triggering a flip-flop on the positive excursions, we can get our red waveforms. And for logic purposes, we probably want the complement of that and this. Divider chips generally will give you this. For the 555, we'll have to add a transistor inverter. That's no big deal. So we'd call these like A, B, C, and D. So for example, red would be all of this. So red on this side, let's say that's east, that's north. So east red would be waveform C. North red at this time would be waveform D, etc., etc. Now for green north, we would want A plus C, so we'll need an AND gate. Yellow north, we would want B and C. So a couple of AND gates, a couple of drivers. Now the thing about an AND gate, a chip AND gate can't drive a LED. So we need a transistor to drive a LED, so why not use two transistors to make an AND gate and a LED driver, which is what I'll do. So let's draw out the circuit. Alright, 555 is easy enough to do. It's got a positive and a negative. That's pin 1, that's pin 4, and pin 8 because there's a reset or something. We have output pin 3. Pin 5 needs a small capacitor, say 0.02 or something for bypassing. With two triggers, which we connect together, 2 and 6, and then there's a capacitor discharge. So we put our timing capacitor on here. It's going to discharge through a resistor through pin 7. Normally they use a resistor up here for charging, but I'm not going to do that because I want more control. And I'm going to put a pot here so we can adjust our overall time, and a pot here so we can adjust our duty cycle for our green-red time, our green-yellow time. which would go in there, and another resistor that I'm going to charge over here. That's our output, our main output. That way I can get any duty cycle I want. How this works, you turn it on, no voltage here. We get a low trigger, sets this high, we get voltage. Voltage comes through here, charges up to capacitor. Capacitor gets to 2/3 voltage. We get a reset through pin 6. That goes low. This energizes and effectively goes low. That's an open collector. So we discharge the capacitor through there. We don't discharge that way because of the diode, so we can get actual control, positive control. That's our output waveform A. And to get B, just a transistor inverter, no problem. That's B. Now to get our square wave here, I'm going to use, I think it's a 4013, is it? Yeah, 4013. Which has got a Q, a not Q clock, and a data input. Now, I'm going to take the output, send it to the clock, connect the data to the not Q so it flips on the positive. So when this goes high, we get our C coming out of our Q, and we get the complement D on the not Q. Start to draw at an angle. That's a C. Alright. So we have our logic A, B, C, and D. That's a C. That's terrible. I can't draw. Especially at an angle like that. See? So, green, north, all we got to do, see, what do we want? We want A, which is the short period. We want C for our AND function, A and C, that guy, send it to a gate. Okay, so I'm going to get rid of this and draw transistor gates. Okay, as I said, lead can't be driven with a logic chip because it needs too much current, so we need to make our own gates and drivers. So a simple driver we have a current limiting resistor, our two lead. These would be red, that's our input. You can make that like a 56K maybe, I don't know. This guy could be a K, or it could be 500, whatever your LEDs require. Probably got 10 volts up here. So as I said, the C would be this red east. So you just connect your C output to here, and that takes care of red east. Another one of these for red north, no problem. Now for Nand Gate, that's really easy to do. We just duplicate this, plus, resistor, couple of diodes, and this time 2 transistors. We're going to get an AND function. Same thing, 56 or so. 56, K, 1K. These would be either the yellows or the greens. Now, turning one of these transistors on is not going to give you any current. You need to turn them both on. That's why that's an AND gate. So for example, green east, you would want signal A and signal D. You would only get the green east during that time. Well, let's go look at the breadboard and see if it works. Okay, I've speeded it up so you can see what's going on. Right now I have about an even duty cycle, as you can see. Green, yellow, green, yellow. I can adjust my duty cycle over here. As you can see, it's a better time for the red. Of course, that's kind of quick. This can just slow that down. Now you have a much more realistic adjustable yellow time. And if I increase my timing capacitor to the proper value, not sure how long this is going to be, but see, I can make that yellow a little longer. I can get it as realistic as I want. I'd have to get my watch and count seconds. I can get quite a bit of time out of this. I think that's my total time. Yeah, it's much more realistic. My point is I can get anything I want.